All right, welcome back. We've spent the last two parts of this journey digging into the very DNA of modern AI, and it all comes down to one single profound idea. So for this final part, we're going to zoom all the way out. We're going to see the full architecture, the hidden engine of intelligence, in motion. So, if you remember, our journey started with what seemed like an impossible task. We took the messy, beautiful, symbolic world of human language, and we translated it into the cold, hard, quantitative language of machines. We gave every single concept its own coordinate. And then we watched as the machines started to learn. It began organizing all those numbers, arranging them into this vast, high-dimensional landscape. A sort of geometric space where the distance between any 2 points, well, that told you how related they were. A map of meaning. Which brings us right here to the final piece of the puzzle. Now that this incredible map of meaning is built, the real question is, what do we do with it? What actually happens when we let an intelligence loose to navigate this brand new world? Because what we're about to see isn't just, a new feature or some clever programming trick. No. This is a fundamental shift in how intelligent systems are even designed. It's a completely new architecture for understanding. And to really get this, you have to understand what I like to call the death of the keyword. For decades, search was just brittle. It was a dumb game of matching exact characters. You, the user, had to guess the right words to please the machine. But vector search flips that script completely. Now, the machine adapts to you because it's not matching words anymore, it's matching meaning. And right here, this is our first huge realization. The search for knowledge, for answers, it's not a problem of linguistics anymore, it's a problem of geometry. Your intent, what you truly mean when you ask something, has become a specific location on a map. So how is this map built? How is it navigated? Okay, let's pull back the curtain and take a look at the actual architectural blueprint for this new kind of intelligence. Now, what's so cool about this is that it shows the entire elegant orchestration from end to end. It all starts with raw, unstructured data just flowing in. Could be text, images, audio, you name it. That data gets broken down into meaningful little chunks. Then, each chunk is encoded into a vector. That's our coordinate of meaning. Those vectors are then indexed into a navigable space, so when your query comes in, the system can instantly retrieve the closest, most relevant information and hand it off to an LLM to synthesize a final coherent answer. It's this beautiful, seamless flow, from total chaos to clarity. And a process like this, well, it needs a very special kind of library. Your traditional database, organized alphabetically or in neat little tables, would be totally useless here. A vector database is different. Think of it as a library for meaning. It's organized by conceptual proximity, not by the alphabet, which allows for this near-instant retrieval of the nearest neighbors to any idea you can think of. Okay, so we have the map, and we have the library. Now we get to see how intelligence actually navigates this space, because it turns out pretty much every major AI application you use today is simply a different way of moving through this landscape of meaning. And this is so crucial to get. Whether you're searching for a document or asking a complex question, the AI isn't hunting for keywords. It's converting your request into a coordinate, and it's looking for what's nearby. It is, quite literally, looking for a location. The most powerful example of this right now is something called Retrieval Augmented Generation, or RAG. This is the system that finally grounds LLMs in reality. See, before an LLM writes a single word, the RAG system first does its homework. It researches the topic by finding the most relevant, up-to-date facts from a private knowledge base. This simple act of looking before you leap basically solves the hallucination problem. And this makes its value so obvious, right? In high-stakes fields like law or healthcare or finance, you just can't afford an AI that makes things up. RAG transforms the LLM from a kind of creative storyteller into a trustworthy research assistant, giving you answers that are grounded, verifiable, and sourced directly from documents you can trust. Now let's look at a totally different way of moving through this space. Recommendation systems. They do something amazing. They map you, the user, into the very same space as all the content. So as you watch movies or listen to music, your personal user vector is moving around. And the system, it then just recommends whatever content vectors are closest to your current location. Proximity becomes a proxy for desire. So far, we've mostly been talking about text. But the true scale of this architecture, this is where things get really profound. We're not just building a space for words, we're building a universal language for all human expression. And this leads to a pretty mind-bending question. Can a fundamentally different types of data, a photograph, a paragraph of text, a piece of music, can they all be mapped to the exact same coordinate in this semantic space? And the answer is a resounding, absolute yes. This is the magic of what we call multimodality. In this unified space, you can use a text query like calm piano music to find an audio clip, or you could upload a picture of a shirt and just ask the system to find it for you, but in blue. We've created a shared language where the meaning of an image can be understood by text and vice versa. It's incredible. And now, for maybe the biggest realization of all. Where does all of this magic happen? We've been talking about it like it's some external system, but the truth is, this is the very first thing that happens inside a large language model. The embedding layer is the front door. Before any reasoning, any thinking can possibly begin, the model has to transform your words from symbols into meaning vectors. Understanding always comes first. But this elegant mathematical space, it isn't some perfect abstract world. It's a mirror, and it reflects the data we feed it, with all of our own complexities, our constant changes, and all of our flaws. And as the architects of these systems, we face some really profound challenges. For one, the space has to deal with semantic drift, the simple fact that a word like cloud means something totally different today than it did 30 years ago. The map is always changing. And it struggles with interpretability. These high-dimensional vectors are basically black boxes, making it incredibly difficult to know exactly why an AI made a certain connection. This space isn't static. It is a living, breathing echo of our culture. So, all of this brings our entire three-part journey to its conclusion. By looking at this new architecture, we arrive at a quiet, but I think incredibly powerful final insight. You know, the entire arc of modern AI can really be understood in three simple acts. First, we translated language into numbers. Second, we organized those numbers into a geometric space where distance is meaning. And finally, we built architectures that can navigate that space, to retrieve, to recommend, to reason, to think. For centuries, we saw language as just a collection of symbols. We now know it has a hidden geography. By mapping the invisible world of human intent, we have finally built machines that don't just hear our words, but can actually begin to understand what we mean. And that really is the ultimate takeaway from all of this. This isn't just about better search engines or smarter chatbots. What we're witnessing is the very beginning of the geometric realization of thought itself. And what we build in that space, well, that's going to define the next chapter of our world.